Okay, welcome back, Philip. This is Philipp Krenn from Elastic. Next, I don't think I have to introduce Philip. He's already presented yesterday, last year, so it's kind of becoming a regular speaker at our conferences.
Well,
Philip,
thanks again for having me.
Yeah. Hopefully the weather is better today in Vienna.
No, it's still very rainy, but I mean, that's the advantage of the virtual conference. I don't have to go anywhere.
Great. So the screen is yours.
Thank you very much. Welcome, everybody. Let me share my screen. Also, let me open the Q&A. If you have any questions, just throw in a question. I will try to keep an eye on this on the side, and I will try to get to your question. No guarantees it will be immediately, but I will get to it. Yeah, I hope your catering is good. So let's get started. Seccomp, the next layer of defense. We want to dive a bit more into the security topic and what you can do around multi-layered security, because security oftentimes is very much this spirit where you say, this is fine. And then, you know, everything is terrible and on fire on you, but you don't want to admit it. That is especially the case when you have this policy in your company that security is everybody's problem, because that normally means that it's really nobody's problem. And then something happens, and I don't know, somebody steals some data, somebody ransoms you for your own data. Something happens in any case, and then you realize that nothing is fine, everything is on fire, and everything is terrible. And you don't want to get to that state. So the idea is, how can we add one extra layer of security to probably avoid this? Obviously, there are no silver bullets. So while vendors will try to sell you products and say like this will solve all of this, I don't really believe that. You will need a lot of different pieces in place to add more and more security or protection and to actually help you fight off the bad stuff, quotation marks. So one of those principles that you want to follow is the principle of the least privilege. So if you don't need some privilege, don't have it or hand it out. In our specific case, don't hand out that privilege to an application. So seccomp is one of the tools that falls very much into that least privilege area. Basically, it prevents certain system calls of an application. So the idea is pretty simple. Let's assume I know that my application never needs to fork out another process, which might be pretty common. Many of your applications probably don't have to do that. With seccomp, you can register a profile, actually this allowing you to do the fork call for your application. So even if you have a remote code execution vulnerability in your application, and somebody could run arbitrary code in the context of your application, they couldn't fork out another process because your application just doesn't have that permission. That's the idea. So you can either abort certain system calls, or you could just kill the entire process because, you know, this is nothing that should happen in my application. So you can just stop it from doing that. And seccomp is really an application sandbox. So for every specific application, you can add these rules, what is allowed or what is not allowed. And then it limits the application and limits it into this sandbox where you can basically set the playing field of these are the things that are allowed for my application. History-wise, so when I say seccomp, I generally only talk about Linux. I will very briefly touch on Windows at the very end. Mac has a similar concept to seccomp, but I've heard that it's less stable and it's also less widely used. So I'm only really focusing on seccomp here, which is kind of like the classic concept around this. So the initial seccomp features or idea was added almost 15 years ago in a very early kernel or very old kernel version. And what you could do back then was you could put an application into strict mode. So basically you could set a 1 in proc, whatever the process ID is, and then seccomp. If you set that to 1, it would set that application into strict mode. And strict mode, as the name implies, is very strict. So it only allows read, write, exit, and seek return system calls. It doesn't even allow you a memory map or any other low-level system calls that you would expect, which has the downside, it is very secure, but it's probably too secure for most real-world applications. But it was a starting point because the concept kept evolving. Like a couple of years later, in 3.5, the basic controls for system call filtering were added, and then 2 years later, Linux 3.17 added a call named seccomp for easier configuration of these seccomp profiles. And since then, you could use it. So hopefully any kernel version that you are using in production supports seccomp. Otherwise, you probably have bigger problems to solve anyway. So what does that look like? When I talk about system calls, this is a Linux server here. So if I run man syscalls, this shows me which system calls are available on this Linux system, and new ones are being added over time in your operating system, so depending on your kernel version. So you can see these are all the system calls that are available on this system, and you can also see when they were added. For example, this one here is a newer one, or you can see the entire list of these are all the system calls that you could allow or deny for an application. And you also see that some of those are platform specific, which we will also briefly touch on later on. So this is what system calls give you. And while we're here, seccomp, this gives you an idea how to use seccomp. So you can set this strict mode. Like we said, it's just overly strict, so it's probably not so useful. Seccomp set mode filter, this is the one that you want to use. And this uses BPF as the format or way to write it, Berkeley packet filter. Where have you probably run into BPF before? If you were doing any network filtering like TCP dump or so, that's also using BPF. So you might have seen that syntax, we'll see later on. It is a bit arcane, or at least if you're not used to it, it is a bit weird, but it is what you can use. And for example, here it gives you examples of what happens if you can fork a process, then the fork process will retain the same restrictions, etc. So this is really the description of what you can do with seccomp. So how do you register a seccomp filter? And as I've said, it's written as a BPF filter. The minimal setup is you need to include these two headers, and well, we're on the C level here. So you need to say this is, you set this seccomp, the filter, and then the pointer to the program. So this is the minimal setup, and then you can actually check out what is allowed and what is forbidden here. So the first thing we're doing here is we are validating the architecture. Like I said, since some system calls are platform specific, you don't want to rely on them being mapped correctly here. We are validating that we are on the expected platform and that we can filter out correctly for that. Then we check a system call. Then we allow the system call to pass through this list of things that will be allowed. And at the end, if it didn't pass through here, we kill the process. So if something was not on this allow list, we will then kill the process and be done with it. And this is how you can implement seccomp at the very basic level. We'll see some more user-friendly approaches as well. So every system call in your system gets filtered through seccomp if you have enabled that. So every single system call triggers a check of your rules. The obvious question is this very expensive? Not really. This is all happening in kernel space, so you don't have to reach out to userland to check for that. So that's why it should be pretty performant to run these. And quite a few performance critical applications actually use seccomp. So I wouldn't worry about the performance overhead too much. The possible outcomes of a seccomp filter are a system call can be allowed, the thread can kill or the process, or an error is returned in addition to logging it. So this is what you can do when system or when the seccomp filter fails actually. So is anybody using seccomp in production? Probably everybody here is using seccomp unknowingly, potentially on a daily basis. So some of the programs that use seccomp are Chrome, Firefox, OpenSSH, Docker, systemd, Qemu, Android, Firecracker, and lots more. So it is pretty widely used. So for example, looking at Docker, it provides a sane default for running containers with some basic security limitations. And it's actually one of the pieces that makes Docker work. It does disable around 44 system calls out of the 300 plus that are around, because those are either not namespace or are not really safe to operate for most containers. So for example, you cannot set the clock from a container because it is not namespaced. So your one container would change the system time for everything. That's why this is disallowed. You cannot reboot the host because that would affect everything else again. You cannot clone or create a new namespace. Just everything that's kind of like breaking out of your context is not allowed by default. Here is a quick example. So this is when you disable seccomp. So here we actually explicitly say running Docker seccomp unconfined. So we disable the seccomp filter, and then we actually unshare and map this to a user account, and then you can run something as root since there is no protection from seccomp in place. Whereas if you run this with the default settings where seccomp is not unconfined, then you cannot unshare and this will just fail. The operation is not permitted because seccomp has blocked out that unshare operation. By the way, there is this concept in Docker that you have probably run into. Its capacity add, and then it could be capacity add, net, or various other ones of those. And this does actually a bit more. So this gives the container the capacity or the capability, and then also allows the system call if it's required. So if something was forbidden on seccomp, but you override it with cap add, the seccomp call would also be affected by that. So this is how cap add actually makes anything work in Docker. When you, for example, want to give a container access to all the networking going on, because in one container you have a network tab running to actually monitor all the network traffic on the host. But you would need to explicitly give that permission, including the seccomp filter, to one container to actually allow that. Is any of your applications using seccomp? You can actually easily check. So you can just grep for seccomp in proc any process status. Let's check this. Oops. And I'm just copying. If I wouldn't lose my focus up. This is the one. You don't want to see me type anything, so I'll just copy paste stuff. Here we have a list of all the processes, and you can see this process ID, for example, this one here uses seccomp. So one would be the classic overly strict one. 2 means it is using a BPF seccomp filter. 0 means it doesn't use seccomp at all. And this is, if I had to guess, potentially or maybe systemd. Let's check it out. So I can just check the process. Okay, and I guess correctly, this one is systemd. We have various other ones. Let's check out this one. What process do we have here? Okay, we have UUIDD. So you can check the processes and see which of your processes are actually using seccomp on your system. So why am I talking about that? We have probably mentioned it already. So I work for Elastic, the company behind Elasticsearch, Kibana, Beats, Logstash. And of course, we care about security as well. And if you look at our stack, so the classic one was Elasticsearch, Logstash, and Kibana. Newer visualization would probably look slightly differently because we have added this lightweight agent or shipper beats. So this is the new logo because there is no bee in elk, and we made up this animal. It's called the belk or the elk bee, and you can see it's an elk and it has a bee body, so it's kind of like the combination of everything. On a more architectural level, this is what the stack would now look like with the beats. So this is the belk or elk bee stack. So you have on basically all your servers out there, you will have beats like this lightweight agent or shipper that can forward data either to Logstash or to Elasticsearch directly. And then Kibana can visualize your data. And in our stack, I want to focus on two components that use seccomp quite heavily. And that is beats, because you run that on all your hosts, and Elasticsearch, because you run or you keep all your data there. Logstash still has an open issue to add seccomp profiles. For Kibana as well, since Kibana is a node process, I'm not sure how far along seccomp or how widely used seccomp is in Node right now. But for beats written in Go and Elasticsearch written in Java, it is in place, and I will show you a bit how that is actually working on a practical level in widely used applications. So in Java, you have this concept called JNA, Java Native Access. So that's how you get to native code access. It is pretty deeply hidden in the source code. I will share the link to the slides afterwards, so you can actually follow the links if you want to take a more in-depth look. I've tried to copy out the relevant code segments from our source code. So what we have here, we do a native initialization of our system, and we're doing two things here. So the first thing is we are checking if you're running as root. This is not seccomp specific. This is just using Linux or any operating system that understands what root is. This does not work on Windows because it doesn't have this root concept. It will check, do you run Elasticsearch as root? So would you run like sudo Elasticsearch, for example? And then it would system exit by throwing a runtime exception, because Elasticsearch does not allow to run your process as root, because it's just a bad practice and we don't allow it. If you would want to run Elasticsearch as root, you would need to comment out these 3 lines and run your own binaries, because it's just not possible with the default binaries. After that, we actually have a seccomp filter. So here, try install system called filter. This is what we are doing next. And you can see that we do support this, at least in theory, on multiple operating systems. But like I said, I will only focus on Linux. So you can see Linux input, this is the one we will focus on. On Mac, we are trying, if possible, as well. SunOS is not officially supported anymore, but we do still try to add that filter if you do manage to run it. Same for BSD, and for Windows, we also run that. Otherwise, we will also exit the process because we say we don't know this operating system. We cannot properly protect it, so we don't allow that. Okay, so other operating systems have similar features, but like I said, we will, or I will only focus on seccomp on Linux. So this is then the profile that we are setting on Linux. So here we are checking the architecture, and then we limit some of the potential system calls that your process could do. So we do not allow a fork, a virtual fork. You cannot run any other binaries. Those are all not allowed, because we know Elasticsearch will never call any other binary on your operating system. So even if we have the remote code execution that I was alluding to before, we could not run any arbitrary other binary, because the process just doesn't have the, it's just not allowed to do that. So this is how this is put together. Like I said, the syntax is maybe a bit arcane, but you can see here, you can see the relevant pieces of what is actually being limited by seccomp. The beats written in Go, for them, we actually have written a nicer wrapper in Go around seccomp calls. which is another open source library that we provide. So it's Go seccomp BPF. This is the wrapper. And then you can just write that in YAML. If YAML is a big improvement or not is really up to discussion or up to the person in question. If you come from more the Kubernetes world and everything is YAML, you will say, well, this is the only proper way to do stuff anyway. We'll embrace it. If you're not so much in the Kubernetes world, you might say, well, YAML is a really tricky format actually, and I don't like it. Unfortunately, this is what you have. So to use this library, you would need to do that in YAML. And this is not an actual sample of beats. This is just a made-up sample. So the default action is allow. So only the system calls that are listed here are being blocked, and everything else is allowed by default. Why is this not the real BPF profile or seccomp profile for beats? Because beats, as a network agent or shipper, needs to connect to other systems to send data. And here we are actually disallowing to connect or to accept the connection, or to send a message, or to bind to an interface, or to listen to an interface. All of those here are not allowed. So this is just an example. Won't be useful for beats as a shipper, but this just gives you an idea how you could limit, for example, if your application does not need to bind or does not need to send any network data. This would be a good way to actually limit that it cannot do that, because there's no point in allowing it. The actual way to do that in beats is hidden a bit deeper, and again you can see it's platform specific. And then you can see this one actually uses the default action is error. So this only allows, like, you need to have everything that you allow needs to be on this list. So you have an action allow. These are the ones that are allowed. And of course, when we add new features to beats and we need new capabilities, then we need to extend this list. And it was a lot of work to put this together, but it is generally the better practice to have this, like, deny everything that is not explicitly allowed, because even if new system calls are being added over time, you will not be surprised by them. Since you don't need them, you can just have them in the catch-all that everything is implicitly denied, and just allow what you really need. So these are alphabetically sorted. A lot of the system calls, this will be a very long list, what is allowed and needed in beats. Like I said, prefer allow over deny. Otherwise, it's a moving target that you try to catch up with. Now, I can give you a very quick example of how this works. So I will just run netcat. I'll make it verbose, and I'll listen on port 1025. Let me try this again. Maybe it's too early for me to type. Okay, or it doesn't like to bind today for whatever reason. Interesting. But just for the sake of the argument, it's not really a demo you need to run anyway. So we're starting the server on port 1025 with netcat, and then I could just connect to that with telnet. So this would be where this is running, and this is the port where I could talk to it, and then you could just have a very simple chat. The point is, by default, every system call is allowed, and then we want to tighten down the system calls, or actually we want to see which system calls are involved in this system. So let's see what system calls are happening here. Since this is fading, this might actually be insightful to see why. And this just tells me, okay, the bind operation for port 1025, maybe the port is already taken, no. The bind operation, for whatever reason, my name resolution does not work here. Normally try to turn it off and on again. Let's see what will happen here. Otherwise, I have all the relevant steps here in the slide, so don't worry. So what you should see with STrace, you can just see all the system calls that are happening, which we will then use to actually forbid stuff in seccomp. So what is relevant here is when you bind with STrace, you will see here, this is the bind command as it happens. And then you can see that this is actually listening on all the interfaces on port 1025. So this is what this bind would be doing. You can also see the complete list of which system calls were used and how many times. This would be a great starting point to actually write a seccomp filter, which allows all the required actions. So you could just run your process and just run it in a normal way to collect all the system calls that are necessary for regular operations. And then you would see which system calls have been used, how many times, maybe that's relevant for you as well, but generally like the list of system calls is relevant. And then you could take that, and this is what you would need as a minimum set of allowed seccomp calls to make this work. There are also more structured ways to report that. So these are two, this is just like a C file living off somebody's website. This is a project on GitHub. These are basically more structured ways to do that reporting for you. But system call filtering or STrace are generally the way to figure out which system calls does a process need. And then they just give you a list of these are the things that you need to allow or expect. Now, how to actually limit it? One library that comes in very handy here is called FireJ. And it allows you to use Linux namespaces, which I'll ignore for now. And you can also sandbox with the seccomp BPF at process. And that is what I want to show you. If my node has come up again, let's see. Yeah, this is when I ran this earlier and it was working. Let's see what we have now. Okay, for whatever reason, my name resolution here is toast. But no worries. You can still see what system calls it is trying to run. So here you could see these are all the system calls that are being used. Now, over to seccomp and FireJ. What I want to do is I'm not using any pre-configured profiles. I'm just dropping privileges as I go along. So what I'm doing here is I'm dropping the bind privilege. So obviously this will make netcat fail because I cannot bind to that interface. So copying that, what I can run here, I have run that and it will tell me, well, this was not allowed since it could not bind to that interface now. You could take a more in-depth look with STrace again to see what is actually happening here. And here you could see we're trying to bind and then it will tell you, well, it killed the process because the bind was not allowed. So this was really, you can see like, these are all the steps it tried. So these are all the system calls we were running through, but the bind was the one that we were disallowing with this call. So this binary now could just not use the bind system call. And with STrace, you can actually see how it runs through all the various steps, but once it hits the bind, this one will be disallowed. And the process is killed. So this is kind of like the relevant part. So one question that comes up every now and then is, let's assume you have a remote code execution in your process and somebody wants to extend the permissions of the permissions or the filters you have set in seccomp. How does that work? Let's say you have three options. One would be you can only set seccomp profiles when you start up the application. The second approach is YOLO, like your application doesn't care if somebody takes it over and is smart enough to change the seccomp filters, all the better for them. And the third option would be you can limit that you can change seccomp filters later on. And it's actually the third option what you can do. So what you would need to do is the very first seccomp rule that you would need to set up is no new privileges. What I'm doing here is, so the very first thing is every privilege that I take away I cannot re-add later on. I can only further tighten down the rules as I go along. So you could start the application, install this, take some privileges away, and after some time, you take away further privileges because, I don't know, the setup of your application has finished, so you don't need some other capabilities anymore. That is possible, but once you have set this, you can never extend your privileges anymore. In Elasticsearch, this is actually set. So no new privs is being set with the Java native access again. And we actually try to do that and break out of that. If that would succeed, we would abort because then our seccomp filter would not have been applied successfully. For beats, we're doing the same thing. We're just setting a flag, no new privs true, and that's all you need and you're done. So this is generally the easier way to do that. So you want to monitor all the things and everything that has gone wrong. So how do you even monitor seccomp violations? There's another Linux tool called Audit, which allows you to audit system calls and events. Unlike seccomp, Audit is just a silent watchdog. It just collects information beautifully, but it won't block anything. Whereas seccomp very actively blocks stuff that it doesn't allow or want. Audit beat, we have wrapped that in another beat or in another library we call Go Lib Audit. And it's basically wrapping the Linux auditing D framework because it is very hard to parse the output of that. So what we do is we take that and make that more usable in our Go agents directly. So there's one agent called Audit Beat where we actually wrap this to collect it. And then you can just search in Kibana to find those seccomp violations. So let's see if this actually succeeded. Here, so this should, let's assume I don't know what I'm looking for. I'm just searching for seccomp. And in the last 15 minutes since my calls were failing, didn't work, but let me head over to the last 24 hours because this worked before, or actually I've just now been talking too much. That's why we didn't see it anymore. Let me filter down to that time frame. If I picked some time frame that made sense, let's try the last 1 hour. Okay, yeah. Here, when we were running this, this is the seccomp profiles. Oh, and these were just the main seccomp calls that I was showing you. This is actually not what I want. Let me show you the real one that worked earlier. So here, this one here was the seccomp call that I was blocking before on that host. So you can see I was using the binary netcat, and this is the netcat OpenBSD process. You can see on which AWS instance this is running. You can see that the actual name of this action is violated seccomp policy. So you could just filter down on that. And then you could see, for example, which user was doing that. So I'm using the Ubuntu user. We have collected it with Audit D. This was the binary that we were running, and you can see this is the operating system where I'm trying to run all of this. So all of this is being collected. This is a bit like when you try to run something as sudo or as root and it's not allowed, and then it will say like this will be reported. Unless you actually watch systems with Audit D, for example, and watch for any violations, you will never be able to find those. But this is exactly what I've done here. So I have Audit Beat running, which just forwards that information into Elasticsearch, and then with Kibana, I can easily show and visualize that. We have also Elastic Security, where you could easily then dump or filter on one specific approach in a more graphical way, where I'm just like, okay, I've seen that that Ubuntu user was doing something weird, so I want to see all the actions that that user has been up to. But I won't go into SIEM or like this entire security suite. It makes filtering down security events much easier, and it's basically a curated view, but you have everything in like the raw logs and just need to enrich them with the right pieces of information so that you can actually dive into them and filter down to the relevant pieces of information. So this is what you want to have or want to do. So to wrap up, this is a bit like a block of Lego. Like I said in the beginning, what you want to have is you want to have this defense in depth where you have many layers, and seccomp is one of the many tools in there that you can use and make sense. One question that comes up every now and then is like, how does this compare to AppArmor, for example? So seccomp, or the similarities are, both of them are kernel level interception filtering techniques that block specific system calls. The difference is seccomp is like set by the process itself. So every application needs to bring its own rules, but the assumption is also that the process itself will know what is needed or not needed for itself. Whereas AppArmor is enforced on for the entire system, and it's not like the specific process doesn't bring its own rules, but AppArmor sets those rules for all the processes. So seccomp is probably a bit more targeted, but it's up to each application's developers. AppArmor is more of a broader tool, but that can also make it a bit harder to use and set up. Seccomp is generally pretty widely available and used, so use it if you can, because it makes a lot of sense. To make that easier, and you don't want to fall back to those pesky JNA calls that I've shown you in Elasticsearch, or you don't want to wrap it in your own library like beats, there is a library called Lipsecond, which is platform independent, and it provides an interface to those system call filtering mechanism. You might ask, why did Elasticsearch not use this? This looks much more convenient. A, we didn't want to have the dependency, and B, we didn't want to have, I think this is written in C, and we didn't want to have a C dependency. So we just run everything natively from Java directly. That's why we don't use Lipsecond in either Elasticsearch since Java or the beats since they are Go, to avoid that C dependency and then running some native code because we just didn't want to add that dependency. But if you want to do that, and it has wrappers for Python and other languages as well. So if you don't want to go that low level yourself, use Lipsecond, which will allow you to actually filter things. On Windows, and I haven't touched Windows in a long time, so take this with a grain of salt. The similar concept, I think, is process mitigation system called disable policy, which the name is already very long, and that's how the entire documentation reads to me. It can do something similar things. It imposes restrictions on what system calls can do. And you will just have to read the actual documentation for that, because I have not tried that out since I haven't touched Windows in a while. With that, do we have any questions? Oh, and I see that I haven't updated the slides here. Normally I would hand out stickers now. Unfortunately, no stickers today. But do we have any questions? Let me stop sharing for a moment. Any questions for Q&A? I see I have a wild hair day today. Looks like my antenna is up. Any questions? Otherwise, thanks a lot for joining me.
Thank you again, Philip.
Sure, anytime. I hope I can see you next year in person again.
Yeah, you too.
Let's see. Let's hope for the best.
Yeah, let's hope it. I mean, thank you for making the time also to join this virtual conference. It's been great having you, although it's always better to have a few beers in person, you know.
Yeah, I must admit it's much more fun in person, but it looks like this is what we have for now. So thanks again for having me. Have a good conference day, and the rest of the week you actually have a very busy schedule.
Yeah, we do. So if you want to check out the sessions, you're welcome to join. Anyway,
I might hang around a bit.
Okay.
Thanks a lot, and over to you and the next speaker. Bye.
Okay. Thank you.